discuss the base question paper today. Okay, let's see the first question. We're asked 36 can be expressed as a product of its primes as. So 36 equals 2 squared times 3 squared, which is option A. In the second question, we're given that in an AP, the nth term an is given by 2n plus 3. So a1 equals 2 into 1 plus 3, and a2 equals 2 times 2 plus 3. And the common difference d equals a2 minus a1, which is, so a1 is 5 and a2 is 7. So a2 minus a1 equals 7 minus 5, which is 2. So option A. In this graph, we're asked how many roots are there for the polynomial. So we can see that the polynomial touches the x-axis at exactly 2 points, and we can also see that it's a parabola. So because it touches in exactly 2 points, we have 2 roots. So it's option C. Okay, so in this question, we're asked which of the following is not equal to 1, the fourth question. So sine square x plus cos square x equals 1, secant square x minus tan square x also equals 1, tan x times cot x also equals 1, cot square x minus cosecant square x equals minus 1. So that's option B. In the fifth question, we're asked if in triangle ABC and DEF, AB by EF so DEF, so AB by EF equals AC by DE. So they will be similar when the angle between them is equal. So angle A equals angle E. So that's option B. In the sixth question, we're given that W, X, Y, Z are real numbers that satisfy W less than X less than Y less than Z. And each of the possible sums of pairs of distinct numbers has a different sum, right? So the 4 smallest sums are 1, 2, 3, and 4. So we'll try and arrange the sums. So W plus X is less than X plus Y is less than Y plus Z, right? Because W is less than Y, so W plus X is less than X plus Y, and y x is less than z, so x plus y is less than x plus z, right? I'm sorry, x plus y is less than y plus z. But also w plus z is less than, I'm sorry, we were supposed to have w plus x here. So w plus x is also less than w plus y, which is in turn less than x plus y, and x plus y is less than x plus z, which in turn is less than y plus z, right? So the only sum of pairs that is left is w plus z, and we'll see that w plus z is greater than w plus y and is less than x plus z, right? So the smallest two sums are definitely w plus x and w plus y, which are w plus y, I mean. So w plus x equals 1 and w plus y equals 2. But we can't really compare x plus y and w plus z with the information that we've been given. So we have two cases. Case 1 where x plus y equals 3 and w plus z equals 4, and case 2 where x plus y equals 4 and w plus z equals 3, right? So from these two equations we have y minus x equals 1. We're just subtracting first equation from the second equation, and if we use this along with this, when we add the two equations, we get 2y equals 4 and y equals 2, and from here we get x equals 1, and we get from this equation we get w equals 0, so we have z equals 4, right? And in the second case, when we use this along with this equation, we get 2y equals 5 and y equals 2.5, and from this we get x equals 1.5 and w equals minus 0.5, and from this equation we get z equals 3.5. So we have what do we have here? We have two possible values of z, and the sum of both the values is four plus 3.5, which equals 7.5. So that's option C, 15/2. So in the seventh question, we're told that the sequence 2, 5, 10, 50, 500 is formed so that each term after the second is a product of the two previous terms. And the 15th term ends with exactly k zeros. What is the value of k? So here we have first term 2, second term 5. And then how is the third term formed? The third term is formed by multiplying 2 and 5. So we have 10, and then 5 into 10, 50, and 50 into 10, 500. So, and so on. So the next term will be 500 into 50, that's 25,000, and so on, right? So can we rewrite this as just a product of two primes? Every term is a product of two primes, that is 2 power 1, 5 power 1, 2 power 1 into 5 power 1, 2 power 1 into 5 squared, 2 squared into 5 cubed, 2 cubed into 5 power 5, and so on, right? So from this we notice that the number of zeros depends on what power 2 has, right? So let's make a table. So for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So so the first term has two has a power of 1, second term 0, third term 1 again, fourth term 1 again, fifth term 2 and 3, and 2 plus 3 5, 3 plus 5 8, 8 plus 5 13, 13 plus 8 21, 21 plus 13 34, 55, 89, and 144 and 233. Right, so the 15th term has the factor 2 power 233, right? So the number of zeros will depend on what power 2 has, and 2 has a power of 233, so the answer is option A, 233. In the 8th question, we're given that A, B, and C are 3 consecutive terms in an arithmetic sequence, then 2b square minus 5ac equals. So if ABC are 3 consecutive terms in an AP, then we have 2b equals A plus C, right? And when we square both sides, we get 4b square equals A plus C the whole squared. And if we subtract 4ac from both sides, we get 4b square minus 4ac equals A plus C the whole square minus 4ac, which equals A minus C the whole squared. And from 2b equals a plus c, if we multiply b on both sides, we also have 2b square equals b into a plus c, right? So if this is equation 1 and this is equation 2, let's subtract the second equation from the first one. We get 4b square minus 2b square minus 4ac equals a minus c the whole squared minus ab plus ac, right? I'm sorry, ab plus bc, and we have 2b squared minus 4ac equals a minus c the whole squared minus ab plus bc, and let's subtract ac both sides. So we have 2b squared minus 5ac equals a minus c the whole squared minus ab plus bc plus ca, right? So that's option A. So we have a 6-digit number A2025B, and it's divisible by 36. 36 divides this number. So 4 divides this number, and 9 also divides this number, right? So if 4 divides this number, the last two digits should also be divisible by 4. So 4 divides 5b. So b equals 2 or 6, right? And also a plus, from this condition we have a plus 2 plus 0 plus 2 plus 5 plus b. So 9 divides this, which means 9 divides a plus b plus 9, which means 9 divides a plus b. So if b equals 2, then a equals 7. If b equals 6, then a equals 3. So the two possible numbers that in this form that are divisible by 36 are 320256 and 72025, and the bigger of the two is this one, 7,20,252. So the answer to this question is option C. Question 10. We're given that a, b, c, d are positive integers, and ab plus ac plus bd plus cd equals 2026, and we're asked the value of a plus b plus c plus d. So if we factorize this, we get a times b plus c plus d times b plus c equals 2026, from which we get a plus d times b plus c equals 2026, and 2026 can be written as the product of its factors as 1 times 2026 and 2 times 1013, and 1013 is a prime number. So, and a plus d or b plus c cannot be equal to 1. because they're both positive integers and neither of them can be 0 or negative. So a sum of two positive integers is always greater than 1, right? So the only possibility that we have is that they both are equal to 2 and 1013 or vice versa, and in both cases their sum, that is a plus d plus b plus c, would be equal to 2 plus 1013, which is 1015. So we have option B. In question 11, we have Ln is defined as the least common multiple of all integers from 1 up to n, up to and including n. So there is a unique integer h such that 1 by 1 plus 1 by 2 plus 1 by 3 up to 1 by 17 equals h by L17. So what is L17? L17 equals LCM of 1, 2, 3 up to 17, right? And what are we told? We're told that h is a unique integer such that this, so h equals L17 by 1 plus L17 by 2 plus and so on up to L17 by 17. So h equals, so L17 by 1 is divisible by 17, so it's 17 times something plus 17 times something plus 17 times something. To even L17 by L16 is also divisible by 17, so that's 17 times something plus L17 by 17. So L17 by 17 is the only term in this sum that is not divisible by 17, right? So the remainder, so we'll have to check. So it's sufficient if we check what the remainder of L17 by 17 is when divided by 17, right? So what's L17 by 17? It's just equal to L16, right? So which equals 2 power 4 times 3 squared times 5 times 7 times 11 times 13, and this can again be written as 16 times so we can combine these two and write 35 times 33 times 39, which again is equal to 17 minus 1 times 17 plus 1 times 17 times 2 minus 1 times 17 times 2 plus 5, right? And from here we'll have a lot of terms that are multiples of 17, and in the end we'll have this exact term left, which is minus 1 times 1 times minus 1 times 5, which equals a multiple of 17 plus 5. So the remainder equals 5, and this becomes much simpler if you use modular arithmetic. And if we used modular arithmetic in in this step, we would get the remainder as 5. The next question is, how many real roots does the polynomial x power 4 plus 2x cubed plus 3x squared plus 2x plus 1 have? So this can be written as x power 4 plus x cubed plus x squared plus x cubed plus x squared plus x squared plus x plus 1, right? And you can check by adding them all, you would get the exact same polynomial. So you can factorize this as x squared times x squared plus x plus 1 plus x times x squared plus x plus 1 plus 1 times x squared plus x plus 1, which equals x squared plus x plus 1 the whole squared. And because x squared plus x plus 1 has 0 real roots, this polynomial also has 0 real roots. So the answer to this question is A, 0. So in the 13th question, we have a large equilateral triangle that has a small equilateral triangle cut from its interior, right? And one entire side overlaps, and the perpendicular distance between them is x, right? And this area of the smaller triangle is equal to the area of this strip that's found, this strip. Right? Which just means that the area of the bigger triangle is twice the area of the smaller triangle, because this area is equal to this area, and if we add them both up, we get twice the area, right? So what we'll do first is draw a perpendicular here. So this is a right angle triangle, and in this right angled triangle, we have this as 90 degrees, this length as x, and this angle as 60 degrees, and then this is 30, right? So this is x by sine 30, which equals 2x by root 3. Is that right? So this is 2x by root 3, and this is also 2x by root 3, right? And if we drop an altitude, we have, if we take the side of the bigger equilateral triangle as z, we have this as root 3 by 2 z, right? And we know z, that is the side of the bigger equilateral triangle, equals 2x by root 3 plus y plus 2x by root 3, right? So this is equal to 4x by root 3 plus y, and the height of the smaller equilateral triangle is just root 3 by 2 times y, right? I'm sorry, is it? It's so this is 60 degrees, this is y by 2, this is root 3 y by 2, this is y. Yeah, that's right. So we have the area of the bigger triangle, that is half root 3, half times root 3 by 2 z times z equals 2 times the area of the smaller triangle, that is 2 times half times root 3 by 2 y times z. Yeah, z is the base. Root 3 by 2 times y times y, right? So we can cancel this out. So we have z squared equals 2y squared, right? And we know what the value of z is, that is 4x by root 3 plus y, the whole square is equal to 2y squared. And from here we have y squared plus 16x squared by 3 plus 8xy by root 3 equals 2y squared, right? Now let's bring the y squared this side. So we have 16x squared by 3 plus 8xy by root 3 minus y squared equals 0. Let's multiply the equation by 3 and divide by y square. So we have 16x squared by y squared plus 8 root 3 x by y minus 1 equals 0. Now this is a quadratic in x by y, right? This x squared by y squared is nothing but x by y the whole squared, right? So we have x by y equals minus 8 root 3 plus or minus, but we can't include the negative root, right? Because a ratio of lengths can't be negative. So it's just the plus square root of b squared, that is 8 squared 64 times 3 plus minus 1 plus 64 divided by we missed the 3 here. So when we multiplied the equation by 3, we got a 3 here. So that's 64 times 3 again, divided by 2 times 16, which equals minus 8 root 3 plus 8 root 6 divided by 8 times 4. So we can cancel the 8's out and we get x by y equals root 6 minus root 3 divided by 4. And that's option D. For the 74th question, that is the 14th question in the maths paper, we have a domino. Okay, the question says a domino is a polyomino of order 2, that is 2 squares joined edge to edge, right? This is a domino, and in this question we have a polyomino of order 8, right? That is an octomino. So we have 8 squares, 1 2 3 4 5 6 7 8, and the octomino is inscribed in a square. And what are we asked? We're asked what is the ratio of the area of the octomino, that is this area, and its ratio to the area of the bigger square, that is to this whole area, right? So what do we do? So what if we took the side of the smaller square, that is the square that's a part of the octomino, as x, right? And consider this small triangle here. Let's draw it on the side. So we have this triangle, and this length is x, and let's say this angle is theta, right? So what do we have? We have this length as x cos theta, and this length as x sin theta, right? And similarly, if this angle is theta, let's draw. So if this angle is theta, this angle is also theta, and this angle is also theta, right? And we consider this small triangle here, this one. This angle is also theta, right? So we have in this square, we have this length as x cos theta, this length as x sin theta, right? And so this triangle is just a 3 times bigger version of this triangle, right? So this length is 3x sin theta, and consider this triangle right here. So in this triangle we have this length, and this is just same as the previous triangle, it's just tilted. So we have this as 3x cos theta, and this small length here is x sin theta, right? So the side of this square in terms of x and theta is 4x cos theta plus 4x sin theta, right? And if we consider this side, right, this side is same as this side, right, because they're two sides of the same square. So we have this length here in this triangle as x sin theta, and in this triangle here, so that's just 5 times of the smaller triangle, right, where this angle is theta. So we have this length as 5x cos theta. So 4x cos theta plus 4x sin theta equals x sin theta plus 5x cos theta, right? And we have, from here we get 4 cos theta plus 4 sin theta equals sin theta plus 5 cos theta. So we have 3 cos theta equals what do we have? We have 3 sin theta equals cos theta, right? So we have tan theta equals 1 by 3, and the area of the domino. So what have we asked? The ratio of we're asked the ratio that equals area of domino divided by area of big square, right? Which equals 8x square, because there's 8 small squares, divided by 4x cos theta plus 4x sin theta the whole square. So this equals 1 by 2 times cos theta plus sin theta the whole square, right? So can we write this in terms of tan theta? So what if we took cos theta common from the denominator? We'll get 1 by 2 cos square theta into 1 plus tan theta the whole square. So this is equal to secant square theta by 2 times 1 plus tan theta the whole square, which equals 1 plus tan square theta by 2 into 1 plus tan theta the whole square, which equals 1 plus 1 by 9 divided by 2 times 1 plus 1 by 3 the whole square. So this equals 10 by 9 divided by 2 times 4 by 3 the whole square, that is 16 by 9. So this equals 5 by 16. So the answer to this question is option B, 5 by 16. In question 15, we're told that there's a triangle ABC and AB equals 12, AC equals 13, BC equals 15. X and Y are placed on AB and AC respectively. So X is placed on AB and Y is placed on AC, right, and they're connected. Such that AXY, so this is X and this is Y, angle AXY is equal to angle ACB. So this angle equals this angle, right? And because it's a triangle and A is a common angle, then this angle should equal this angle, that is AYX should equal ABC, right? So we have angle AXY equal to angle ACB, angle AYX equal to angle ABC, and angle A common. So the two triangles are similar by AAA similarity, right? So AXY is similar to ACB. And because they're similar, we have AX by AC equals AY by AB equals BC, XY by BC. So AX equals XY times AC by BC, which is, so XY is given as 6, so we have AX equals 6 times AC, which is 13, by BC, which is 15, and AY equals 6 times 12 by 15. And we're asked what is AX plus AY. So AX plus AY equals 6 times 12 plus 13 by 15, which equals 10. So the answer to this question is option D, 10. Alright, in question 16, we're given two identical square sheets of paper, which each side length 6, and they're stacked on top of each other, and about its center, the sheet on top is rotated clockwise 30 degrees, right? So if it's rotated clockwise 30 degrees, then this angle should be 30, right? And what else? So yeah, there's a 16-sided polygon produced, and that's this one. And they're saying that the area of the polygon can be expressed in the form a root b, where a and b are positive integers and b is not divisible by the square of any prime. They're just saying a root b is the lowest form, right? So first we need to find the area. So to do that, what do? So these triangles are all identical, right? So they all have the same area, and the remaining area is just the area of the square, right? So what do? So let's take this length as x and this length as y, right? So because this is symmetric, we have this also equal to x and this equals y, right? And this also equals y, right? And so on. So what do we have here? So in this triangle, we have one side as x and one side as y, and one of the angles as 30 degrees. So x by y equals tan 30. So y equals x by tan 30, which is x by 1 by root 3, which is root 3x, right? So this whole thing here is so x root 3x and root 3x, and this length is the square root of x squared plus root 3x the whole square, that's 3x squared, which is 2x. So the side of the square is 3x plus root 3x, which equals 6. 6 is given in the question, right? So now what do? We know x and we know y. So the area of the triangle is half times xy, which is half times root 3x squared, which equals half root 3, 6 divided by 3 plus root 3 the whole squared, and 6 by 3 plus root 3 equals 6 into 3 minus root 3 by 6, right? So it's just equal to 3 minus root 3, right? So we have the area of triangle equals half times root 3 times root 3 minus root 3 the whole square, and the area square equals 6 square. So what do we need? The area of the polygon equals 6 squared plus 4 times the area of the triangle, that's 4 times half root 3 times 3 minus root 3 the whole squared, which equals 36 plus 2 root 3 times 3 squared, that's 9, plus root 3 squared, 3 minus 6 root 3, which equals 36 plus 24 root 3 minus 36, which equals 24 root 3. So what are we asked? So this is in the form a root b, and we need to find a plus b equals 24 plus 3, which is 27. So the answer to this question is option D, 27. So in question number 77, that is question number 17, we're told that the angle of elevation of the top of a tower from the foot of one person standing due south. Okay, let's draw a tower, and a person is standing due south, right? The angle of elevation is 45 degrees, and another person standing due west, the angle of elevation is 30 degrees. and the height of the tower is 5 meters, and there, what are we being asked? Then the distance between these two people, right? So all these are right angle triangles, this one and this one here, and this one here. All three are right angle triangles, and we can use the trigonometric ratios here. So if this is 5 meters, then this length is what? It's, so this by this is, so this by this is cot 30. So this is 5 cot 30, which is 5 tan 60, which is 5 root 3, and this is 5 cot 45, which is just 5, right? And this length is just 5 root 3 the whole square plus 5 square whole thing under root, which is 10. So the answer to this question is option A, 10. So what are we being asked in this question? The sum of two natural numbers is 18,095. One of the two numbers is divisible by 10, so the unit digit is 0, and if the unit digit of that number is erased, that is, if 0 is erased, then the other number is obtained. So here we have one number, that is A, and or rather 10A, because it's divisible by 10, and erasing the last unit digit of 10A is just dividing it by 10, right? So we have 10A plus A equals 18095, and what are they asking? The difference between the two numbers. So they're asking 10A minus A. So 11A equals 18095, and they're asking 9A, right? So 9A equals 18095 by 11 into 9, which is equal to 14,805, which is option B. Alright, in the 19th question, what's being asked? So a student multiplied the number 66 into 1 point AB bar, right? But he did not notice the notation, so he just multiplied 66 into 1 point AB, right? And he found that his answer was 0.5 less than the correct answer. So the correct answer is this, and this is 0.5 less than the correct answer. So 66 times 1 point AB plus 0.5 will be equal to 66 times 1 point AB bar, right? And 1 point AB is just 1 plus 0 point AB, and 0 point AB is AB by 100 plus 0.5 equals same thing here. This is 1 plus 0 point AB bar, which is just AB by 99. And if you don't know how to do this, 0 point AB bar, take this as x, then 100x will be equal to AB point AB bar, and 100x minus x, that is 99x, equals AB point AB bar minus 0 point AB bar, which is AB. So x equals AB by 99, right? So here we have 66 plus 66 AB by 100 plus 0.5 equals 66 plus 66 AB by 99, and we can cancel the 66's out, and we have 66 times AB by 99 minus AB by 100 equals 0.5. And 66 AB times 1 by 99 times 100 equals 0.5, and this is 2 times 33, and this is 3 times 33, and 50 times 2. So AB equals 0.5 into 3 into 50, which equals 75. So the number that we need, the 2-digit number AB, is 75. Alright, let's look at question number 20. So we're given a rectangular grid in which all these lines are 1 unit apart, right? So what is the sum of lengths of the line segment that form this acronym, right? So in P we have this one line, this vertical line, this vertical line, and this vertical line. So all of them have equal lengths, and that is 9 minus 1, 8, right? So 4 times 8, and all these lengths are same. This one here is 3 units, this one is 3 units, this one is 3 units, 3 units, 3 units, 3 units. So 6 times 3, and this length here is 4 units, so 4. And what is this length? So we can use the distance formula. So the coordinate of this point is 4, 9, and of this point is 1, 6, right? So we have 4 minus 1 the whole square plus, this is not 4, 9, this is 5, 9. So we have the distance equals square root of 5 minus 1 the whole square plus 9 minus 6 the whole square, which equals 5. And similarly for this length here in A, we have this point as 9, 8, and this point as 2, 1. So the length of this is this is 8, 9. So we have 8 minus 2 the whole square plus 9 minus 1 the whole square under root, which is square root of 6 square plus 8 square, which is 10. So plus a 10 plus a 5, which equals 69 units. So the answer to the 20th question is option B, 69. Alright. Let's look at this question number 81, with the 21st question in the maths paper. So what's being told. In the square ABCD, points E and H lie on AB and DA. So these 2 points right here, this one and this one, right? So that AE equals AH, this equals this, and FI is perpendicular to EH, so EH is joined and FI is perpendicular to EH, and GJ is also perpendicular to EH. So what are we told? We're told that this triangle has area equal to this quadrilateral, has area equal to this pentagon, has area equal to this quadrilateral. Now if you notice, these angles are 45, these angles are 45, and these angles are 90, these angles are 135, and this diagram is symmetric, right? Now what are we being asked? We're being told that all these areas are also equal to 1, and we're asked what is this length squared, right? Now let's extend EH to a point O where it meets CB, when CB is also extended, right? So we're extending this, and let's drop a perpendicular from C to EH, right? So there we go. So let's see. So the area of the square is the sum of areas of all these regions. So area of the square equals 4, right? So the side of the square is 2, and AE equals AH, and the area of AHE equals 1, which is equal to half AE squared, or AE into AH, which can be written as AE squared. So AE equals root 2, right? So this length here is root 2, this length here is 2 minus root 2, right? And what else can we find? Take this triangle here, EBO, right? We have this angle also as 45, because this angle is 45 degrees, this angle is also 45 degrees, right? So EB is also equal to BO, so this length is equal to this length, which is equal to 2 minus root 2, right? And what is this whole length? CO. So CO equals 2 minus root 2 plus 2, which is 4 minus root 2, right? And can we also calculate, so let's say this altitude meets EH at M, right? So CM equals right? Even this angle is 45 degrees, right? So CM is equal to what? So CM by CO equals sine 45. So CM equals CO by root 2, which is equal to 4 minus root 2 by root 2, which equals to root 2 minus 1, right? And what do we have? We have, so this, because this diagram is symmetrical about the diagonal, we have this area equals this area equals half of this total area, and the total area we know is 1. So this area is half, right? And how can we get that area? That area is just this whole area, that is the area of triangle COM, minus this area of this triangle, that is area of triangle FOI, right? So area of triangle COM minus area of triangle FOI equals half. Now, what is the area of triangle COM? It's half into CM into OM, both of which are equal. So half into CM squared minus area of triangle FOI, that is half into FI into IO, which are both equal. So half FI squared, right, which is equal to half. So we know what CM squared is. So 2 root 2 minus 1 the whole squared, half times that, minus half FI squared equals half. And from here we get FI square is equal to 2 root 2 minus 1 the whole square minus 1, which is 8 plus 1 minus 1 minus 4 root 2, which is equal to 8 minus 4 root 2, which is option A. Alright, let's move on to the 82nd question. So we have a right triangle ACD, which is also isosceles. We have a right triangle ACD, that is this right triangle here, which is constructed outwards on the hypotenuse AC of right isosceles right triangle. This is the isosceles right triangle ABC, right, where AB equals BC equals 1, so that the two triangles have equal perimeters, right? So 1 plus 1 plus AC equals AC plus CD plus AD, and we can find AC out. AC equals square root of 1 square plus 1 square, which is equal to root 2, right? So the length of AC is root 2, and so what are we being asked? Oh, we're given that sine 2 theta is 2 sine theta cos theta, and we're being asked what is cos of 2 times angle CAD. So let's say angle CAD is alpha. Alright, so what is CD? CD is root 2 tan alpha, and AD is root 2 sec alpha, right? And we can cancel AC out here, so we have 2 equals root 2 tan alpha plus root 2 sec alpha. So from this we have root 2 equals tan alpha plus sec alpha, and root 2 minus tan alpha is equal to secant alpha, and root 2 minus tan alpha the whole squared equals secant square alpha, right? And secant square alpha is nothing but 1 plus tan squared alpha. So we have 2 plus tan squared alpha minus 2 root 2 tan alpha equals 1 plus tan square alpha, right? So this gets cancelled, and we have tan alpha equals 1 by 2 root 2, and from this we have secant square alpha equals 1 plus 1 by 2 root 2 the whole squared, which equals 9 by 8. So cos square alpha equals 8 by 9, and we're also given, okay, and because we are only dealing with acute angles, cos alpha equals 2 root 2 by 3, and from here sin alpha equals square root of 1 minus 2 root 2 by 3 the whole squared, which equals square root of 1 minus 8 by 9, or square root of 1 by 9, which is 1 by 3. And what are we being asked? We're being asked cos 2 alpha is what we have to find, and we're given sine 2 theta equals 2 sine theta cos theta. So sine 2 alpha equals 2 sine alpha cos alpha, right? So sine 2 alpha equals 2 times 1 by 3 times 2 root 2 by 3, which is equal to 4 root 2 by 3, and cos squared 2 alpha equals 1 minus sine squared 2 alpha, which is equal to 1 minus this is 9 here, so 1 minus 32 by 81, which equals 49 by 81. So cos 2 alpha equals 7 by 9. So the answer to this question here is option C, 7 by 9. What is the sum of all possible values of k? So in question number 23, we're given two quadratic polynomials, x square minus 4x plus 3 and x square minus 7x plus k, and they have at least one root in common, and this is factorized as x minus 1 times x minus 3, and the roots are 1 and 3. And if so, case 1, common root equals 1, then 1 square minus 7 times 1 plus k equals 0, and k equals 6. And case 2, common root equals 3, then we have 3 squared minus 7 times 3 plus k equals 0, and k equals 12. So the sum of all possible values of k is 6 plus 12, which is 18. Alright, let's see question number 84. So n factorial represents the product of all positive integers from 1 up to n. So n factorial is 1 into 2 into 3 into 4 up to n, right? And we're also shown with an example what 5 factorial is, that is 5 into 4 into 3 into 2 into 1, right? So from this we can see that n plus 1 factorial is just 1 times 2 times 3 times up to n times n plus 1, which is just n factorial times n plus 1, and n plus 2 factorial is just n factorial times n plus 1 times n plus 2, right? And so we can rewrite the equation that's given as n factorial into n plus 1 plus n factorial into n plus 1 into n plus 2 equals 360 times n factorial. So we can cancel the n factorials out, and we have n plus 1 plus n plus 1 times n plus 2 equals 360, and this is n square plus 4n plus 3 equals 360, and n squared minus plus 4n minus 357 equals 0. So this factorizes as n minus 17 times n plus 21 equals 0, but the factorial notation is a product of all positive integers from 1 up to n. So we only take n equals 17, right? And the sum of digits of n is 1 plus 8, 1 plus 7, which is 8, right? So the answer to this question is option A, 8. Let's see question number 85. So it says a circle has 0, 0 and 20, 26 as endpoints of a diameter. So the circle's endpoints of a diameter are 0, 0 and 20, 26. So what are the coordinates of the center of the circle? That is just the midpoint of the ends of the diameter, right? The midpoint of the diameter is the center of the circle. So to calculate the midpoint, we use the midpoint formula, that is 0 plus 20 by 2, 0 plus 26 by 2, and that is 10, 13. Option B. Alright, let's see. In this question, we have x plus 4 equals y minus 2 the whole squared, and y plus 4 equals x minus 2 the whole squared. And because these equations are symmetric with across x and y, x equal to y could be a solution, but we're explicitly told that x not equal to y. So let's subtract the two equations. We'll get x minus y equals y minus 2 the whole square minus x minus 2 the whole square, which is equal to y minus 2 minus x minus 2, which is y minus x, times y minus 2 plus x minus 2, which is x plus y minus 4. So from this we get x plus y minus 4. So we can cancel the x minus y and y minus x, right? Because then x and y are not equal. So that's not a solution. So x plus y minus 4 equals minus 1 is one of the solutions. So x plus y equals 5. And let's also add the two equations. Then we'll get x plus y plus 8 equals x square plus y square minus 4 times x plus y plus 8. Right? The 8's get cancelled, and x squared plus y squared equals 5 times x plus y, which is 5 times 5, which is 25. Option C. So in the 27th question, we're told that we're making staircases using toothpicks. So a 3-step staircase uses 18 toothpicks. So let's see how a 1-step staircase will be. So in a 1-step staircase, we'll use 4 toothpicks. For a 2-step staircase, is 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10. So 4 plus 6 toothpicks, and in this we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus 1, 2, 3, 4, 5, 6, 7, 8. So 4 plus 6 plus 8 toothpicks, and if we're gonna add another step we'll have 1 2 3 4 5 6 7 8 9 10, so another 10. So 4 plus 6 plus 8 plus 10. So if you see the total number of toothpicks that are being used are just the sums of an AP. So for number of steps and number of toothpicks, so for one step it's 4 toothpicks, for 2 it's 4 plus 6, for 3 steps it's 4 plus 6 plus 8. So this is sum of one term, sum of two terms, sum of three terms, and so on. So in this AP, so what are we asked to find? So we're told that sum Sn is equal to 270 and we're asked to find n, right? So in this AP, the first term is 4 and the common difference is 2. So Sn equals n by 2 times 2a plus n minus 1 times d, which equals n by 2 times 2 times 4, that's 8, plus n minus 1 times 2, that's n times n by 2 times 6 plus 2n, which is n times n plus 3. So n squared plus 3n minus 270 equals 0. So we have n minus 15 times n plus 18 equals 0, so n equals 15. So option D, n equals 15. And let's move on to question number 28. In this question, we're given that alpha is a 0 of x power 4 plus x square minus 1, which means that alpha power 4 plus alpha squared minus 1 equals 0, and we're asked to find the value of alpha power 6 plus 2 alpha power 4 the whole power 1000. Alright, so alpha power 4 plus alpha squared equals 1. Let's multiply both sides by alpha squared. So we have alpha power 6 plus alpha power 4 equals alpha squared. Now let's add alpha power 4 both sides. So we'll have alpha power 6 plus 2 alpha power 4 equals alpha power 4 plus alpha squared, which in turn is equal to 1. So alpha power 6 plus 2 alpha power 4 equals 1, and 1 power 1000 is 1. So the answer to this question is A, 1. So let's see the 89th question. We have 4 cos theta minus 1 equals 2 sin theta tan theta. So 4 cos theta minus 1 equals 2 sin squared theta by cos theta. So 4 cos squared theta minus cos theta equals 2 minus 2 cos squared theta. So from this we have 6 cos squared theta minus cos theta minus 2 equals 0, and cos theta equals 1 plus or minus under root 1 minus of minus 2 times 4 times 6 divided by 2 times 6, which equals 1 plus or minus square root of 1 plus 48 by 12, which is equal to 1 plus or minus 7 by 12. And we're given that we've been given that cos theta is greater than equal to 0, so we'll ignore the negative sign here. So cos theta equals 1 plus 7 by 12, which is 8 by 12 or 2 by 3. So we're asked what the value of tan theta is. So sin theta equals, or square root of 1 minus cos square theta, that is 4 by 9. Oh, I'm sorry. Which equals square root of 5 by 3. So tan theta equals root 5 by 2. Number 30, we have that the second, third and fourth terms of an AP are 2k, 5k minus 10 and 7k minus 14. So 2k, 5k minus 10 and 7k minus 14 are in an AP. So we have 2 times 5k minus 10 equals 2k plus 7k minus 14. So 10k minus 20 equals 9k minus 14. So k equals 6, and which means a plus d equals 12 and a plus 2d equals 20. So d equals 8 and a equals 4, which means that the sum of n terms Sn equals n by 2 into 2a plus n minus 1 times d, which is n by 2 times 8 plus n minus 1 times 8, which is n by 2 into 8n, which equals 4n squared, which is not always a multiple of 8 but always a perfect square. So it's option A.